Find in practice Assembler being used in startup teams?
Well, startup teams tend to come to Assembla and just pick the tools they already know they need. They need a repository, they need a task and ticketing system. As they start to get bigger, then they start to think about some of the things that we've done to help them manage distributed teams, like this daily stand-up report that we built in. It's a very simple feature, really great for managing and collaborating and getting together. As they start to get more sophisticated, they start to think about not only their agile methodology, are they going to be Scrum or XP, how often are they going to release, and so on, but they also start to think about code contribution methodology. And one of the things that's really interesting that we've noticed in coming out of the open source world is that there's sort of two streams of sort of important management streams about how you manage your project. One is the project management methodology. How frequently do you release, and how do you talk about that? How do you plan out your releases? That's what conventional Scrum methodologies are concerned about. But the other really, really hot area is code contribution methodology. Literally, how does the code get into your build?
Right.
And that's where the major innovations in software development have actually been. And at Assembla, we try to participate in that at the right level. So in the beginning, when there were no source code management systems and people had to sort of swap code back and forth on floppies, I actually remember those days. Then we got source code management systems like CVS and now Subversion that are essentially merge-oriented. Well, actually, there was a time when source code management systems had something called lock.
Right.
You could lock a file and say, I'm going to work on that, and then nobody else would work on it. And that was useful. That made it possible to work together in a bigger team. But then people said, well, that's blocking. Now, only one person can work at a time. What if they go home or if they're sick? We should have a merge process where two people can work on it at the same time, but the source code management system will help us merge. And that's a really useful thing to be able to do, but it does have a scaling problem. And the scaling problem is that you can only have a certain number of people working on your code before you start getting broken builds.
Right.
Before statistically, one of those people is going to make a mistake and cause a problem for everyone else. So we got a new generation of systems that, like Git and Mercurial. Linus Torvalds sort of specifically designed a system around the idea that people weren't going to push and merge code into his code base. He would go out and pull from contributor repositories. So they would each have their own code, and he would pull it. And you have wonderful systems like GitHub with their social coding that support this process. And that's something that at Assembla we're working really hard to sort of understand and support in a better way, this pull methodology. But that methodology itself has a scaling problem because there's only a certain amount of code that one maintainer, that's what the person is called, can pull and test.
Right.
And so we started looking around for ideas about how to solve that scaling problem, and we stumbled on something called Gerrit, which is used in the Android project. And one of the new things we're going to be coming out with is Gerrit on demand.
Okay.
And what Gerrit is a Git workflow. It's a code contribution workflow that is different from the, I'm going to pull from my contributors workflow. What Gerrit allows you to do is everybody puts their change sets into a bin, and there's a discussion thread that gets associated with that for code review, and people can vote on it. So you can have an expandable number of experts that vote, not just one contributor or a small number, but an expandable number that vote on this code. And you can also set up build systems like Hudson to run tests with just one change set. So you can do a lot of automated testing for each change set.
Interesting. So it's almost like a political element of voting on the features which are the most important, or is it mostly voting to ensure
it's not
that
prioritization. It's voting to decide whether a change set goes into the master build.
Right.
And that's what you want to know in a code contribution methodology. And so you can see that there's a lot of advances on the sort of the side of literally how the code goes in that are different from the project management side. And we try to understand both sides and help people fit themselves into the workflow that's right for them.
So it's more a collaborative gating system to ensure that the code that is committed on the ongoing basis matches the roadmap that's being
Well,
applied
to make sure
as a
that it
project.
works.
Yeah.
Yeah, and if you think about what's important about agile development is getting to releases.
Yeah.
And the reason that automated testing is so important is because you can release more frequently if you can run your tests more frequently. You have to test what you release. If you have a very efficient process for testing and evaluating the new code that comes in, you can release continuously.
Right.
And that's sort of the nirvana that you want to get to if you have a big system and a big team. And this is going to take us to a very different place than where we are now. So the software industry is really, over the last 15 years, has experienced some tremendous successes. The internet has taken over the world. The software business continues to grow. The geeks are the Fortune 500, richest list. And this has been a great time for the software industry. What's really been happening during those 15 years has been a migration to smaller teams. So over the last, I use the word, it's somewhere between 10 and 15 years. During that time, the amount that a small team of a few people can do has increased about 5 times. It's been a period of massively increasing productivity. So the winning strategy for people who make software has been to squeeze their work down to the point where a small team can do it. And since they can now do projects that are 5 times as big, they're 5 times as productive. It's been a great strategy. But if you look further back in the history of the software business, you'll see that the most expensive thing that people do with software is scaling and managing big teams. And in fact, there's a classic book called The Mythical Man Month that was written about this, that I often talk about, that people still read. It was written in the late 60s, early 70s, and people are still running into the exact same problems when they try to do big projects like a mobile phone operating system, for instance, something that's hot right now. And so scaling in big projects is still the most expensive problem in software, and it's been an area of great frustration. But what we're trying to look at Assembla, we've traditionally supported small teams. Everybody that uses Assembla now is in a small team. And as I said, those small teams are very successful. We can help them be more successful for, tiny amounts of money. We can make that process really rock. But what we're looking to innovate in is to really turn our attention to some of these problems that no one else has looked at, or as people have turned their attention away from, which is these problems with scaling and what happens if you have these bigger projects. And in that case, you could look at a project management solution. You could try to scale up Scrum, and you could say, well, Scrum, we can scale up Scrum by having a pyramid of Scrum teams. Scrum teams tend to be small, 5 to 10 people. In fact, that's the whole idea of Scrum, is to work in a small team that's self-managed. But the problem with that is that now you're going back to this hierarchical management where the people at the top have to know what's going on, and that doesn't work very well because they don't. They're not omniscient. And so you've reproduced the whole management structure you were trying to get away from with all of its problems if you do this Scrum of Scrum things. It's possible that some of these ideas around code contribution can actually make the difference. That if I can have hundreds of people contributing code to one project, I won't have to chop them into small teams and then intensively allocate out the tasks. That's the thing that doesn't work very well for each of these teams. So we're hoping to bring in some of these new ideas for more scalable projects. And cloud computing actually starts to become very important in that, because one of the things that you have to do to build software is you have to stage and test your software. And what I find when I work with bigger customers is they actually have a lot of trouble getting these staging environments. And a lot of effort is expended into planning out who gets what test environments and so on. And anytime you have to plan something from the top down, it's a scaling problem. You're going to have trouble getting the attention of management. If you can just reach out on demand, if any developer who's in this, at the bottom, think of it as a pyramid, at the bottom of the pyramid can reach out and grab the resources that they need to do, for instance, full system testing, then you've massively increased the scalability of your process.
Interesting. Well, it's a lot of things to think about. So I think maybe next we could talk a little bit more about distributed teams.